Alright class, today we're going to go over properties of logs, and again you saw this last year, so hopefully this is a refresher, and some of you guys were actually talking about these properties when we were doing the stuff from 4.4, so now we're going to actually talk about them. So first thing you need to remember is that a log represents an exponent. Okay, that's all it is we're rewriting an exponential form and setting it equal to the exponent. So remember some exponent rules that we had from before. When you are multiplying the same base, for example, you add the powers. So, for example, when multiply, add the exponents. When you raise a power to a power, so there should be before the parentheses something, let's say it's 6th to the 3rd. That's the same thing as saying x of 6 times 3. So power to a power you multiply. And finally, when you divide an exponent, you subtract. Okay. So those are all review. Exponent powers, you saw them since Algebra 1. Alright, so now we're going to talk about the logarithm rules, or the log rules, and they kind of follow the same process. So the first one is, if I have log base b of something, I'll say x times y. That is the same thing as saying, because it's multiplied, you can separate the exponents by addition. Okay? When you have power to a power, you end up multiplying the exponents. So that turns out to be log base b of x to the y. You can end up multiplying y times the exponent log base b of x. You bring it down in front. And finally, with division, you get log base b of x over y turns into log base b of x minus log base b of y. So those are your log properties, and they follow very closely to the exponent rules, and you guys should know those already. So let's look at some of these problems without a calculator. First one, evaluate without a calculator. Well, I notice, and again, it has to be the same base, so it is the same base. I have addition. When the exponents are being added, that's when these were being multiplied. So we can say we have log base 6 of 4 times 9, which is equal to log base 6 of 36. Now, at this stage, you can do a couple things. Again, you can just note, well, what exponent gets me from 6 to 36? And it's 2. The other thing you can do is rewrite 36 so it matches, and then bring this down. Excuse me. So we get 2 log base 6 of 6, and you should remember that when you have log base 6 of itself, the power that gets you there is 1. So this is 1. So the final answer is 2, basically, either way you look at it. B is the same type of property. Bring the 13 down in front, and then we have log base 2 of 2. And again, the exponent that goes from 2 to 2 is just the 1. So we get 13. Here we have to put these together, and since it's subtraction, that happens when the things are being divided. So log base 8 of 16 divided by 2, which is equal to log base 8 of 8, and we know that that is just 1. Alright, given that log of 3 is A and log of 5 is B, write the following in terms of A and B. So I'm telling you basically I need to get 5s and 3s. So hopefully you know that 15 is 5 times 3. And then we're going to use the property that we know to split them up. So this is log 5 plus log 3. And then in the problem, I told you that log 5 was b, so this is b plus log 3 is a. So this is just b plus a. b plus a. Over here, we have subtraction. So we have log of 5 minus log of 3 because there was division, which means the exponents are being subtracted. So finally, we can fill in our letters. Again, log 5 is b, log 3 is a. So this one's b minus a. Log of 25 we can rewrite as log of 5 squared. I can bring the 2 in front and multiply it times log of 5, and log of 5 is b, so this is just 2b. So that's how you do those. You have to just split them up based on the 5s and the 3s and your properties, and then sub in the letters a and b when you can. Now we're going to expand. Okay, this is when we're making it all into individual logarithms. To expand this one, we have log base 3 of x minus log base 3 of 9. And then what I would like you to do when you see simple numbers like this, again, what exponent do you use to get from 3 to 9? Well, if you square 3, you get to 9, so that turns into just a 2. This is the same thing as saying 2. Here, the only thing we can really do with this is bring the 5 down. When you expand, we want the coefficients in front. We don't want powers. And that's it. We can't do anything else there. Now we're going to condense. So we're putting them back together. So to put them back together, the powers need to go back up. So first thing you do is move any powers up. So I have log base 3 of u squared minus log base 3 of v. And now that the power's up, I can put these together in one logarithm. Log base 3 of u squared is on top of v. And that's one logarithm. There we go. Here again, I need to get these numbers up. So I get natural log of x to the 5th plus, that should be a 5, plus natural log of y to the 3rd. And now because there's a plus, that means we end up multiplying here. So we have natural log of x to the 5th and y cubed. And that's it. That's expanding and condensing. So that is the first day of log properties. Again, you have seen these before, but hopefully this was a nice reminder of how to do these. And I will see you again next time.